Everyone, myself Sabriza Yasin Ahmed. Today I am here to teach you the first chapter of class 10 NCERT, that is chemical reaction and equation. So what is a chemical reaction? So what is a chemical reaction? A chemical reaction is when one or more substances change into new substances with different properties. It occurs when the nature and identity of the initial substances change. That means if the nature and identity of the initial substance change, then we can say a chemical reaction is taking place. This happens in everyday situations like milk souring or iron rusting. What does this milk souring or iron rusting means? Milk souring means milk naturally contains a sugar that is known as lactose, okay, and that lactose gets converted to lactic acid in presence of a bacteria known as lactobacillus. Okay. So here what happened here the nature and identity of the initial substance change. That means lactose get converted to lactic acid. So here a chemical reaction is taking place. Now what is iron rusting? Iron rusting means when iron is exposed to moisture, it reacts to form hydrated iron oxide. Okay, so what is the formula of hydrated iron oxide? Fe2O3 water. This is the formula of hydrated iron oxide, and this is also known as rust. Okay, hydrated iron oxide is known as rust. So what is the chemical reaction that takes place here? So the chemical reaction is iron plus water plus oxygen. First it get converts to ferric hydroxide. Okay, wait. So iron plus water plus air. First it gets converted to ferric hydroxide. Okay. After that it gets converted to hydrated iron oxide, that is known as rust. So what does moisture means? Moisture means water and air, right? So when water and air reacts with iron, first it gives ferric hydroxide, which is then later converted to hydrated iron oxide, which is known as rust. So next, केमिकल रिएक्शन होने से क्या क्या होता है? सो केमिकल रिएक्शन होने से चेंज इन स्टेट होता है, चेंज इन कलर, गैस इवोल्यूशन, टेम्परेचर चेंज होता है. सो व्हाट डज चेंज इन स्टेट मीन? चेंज इन स्टेट मीन सॉलिड बिकमिंग गैसेस और लिक्विड्स बिकमिंग सॉलिड. सो व्हाट डज दैट मीन? आई विल गिव यू अ वेरी सिंपल एग्जांपल हियर. व्हेन ice gets converted to water and then it gets converted to steam. So what is happening here? Here the physical state is changing. This is a very basic example of change in state. So now I will give you a chemical change in state example. Okay, so that is zinc solid plus HCl aqueous gives zinc chloride aqueous plus hydrogen gas. So okay, let me explain here. S means solid, AQ means aqueous, and G means gas. Okay, so what is happening here? The solid state, zinc solids get converted to zinc chloride, that is aqueous form. So here the change in state is taking place, right? So and this is also an example of displacement reaction. Okay, there are many types of chemical reaction, that is like combination reaction, displacement reaction, decomposition reaction, and double displacement reaction, that is mentioned in the NCERT. And this is an example of displacement reaction. Here zinc reacted with chloride and displaced hydrogen gas, right? As you can see here, zinc react with chloride and displace hydrogen gas. So it is an example of displacement reaction also, and change in state is also occurring here. Okay, now let's come to the next point, that is change in color. What does change in color means? Change in color means a visible alteration in the substance hue, right? So जब कलर चेंज होता है रिएक्शन का, then we can say a chemical reaction is taking place. So let's see an example. Copper sulfate is normally blue color solution. Okay, copper sulfate solution is normally a blue color solution, but when we add zinc to it, it becomes colorless. Okay, so what is the chemical reaction that is taking place here? zinc solid plus copper sulfate aqueous reacts to form zinc sulfate. Okay, this is zinc sulfate plus copper. So what is happening here? Here this copper sulfate is blue in color. Okay, copper sulfate is blue in color and zinc sulfate is colorless. So what is happening here? The blue color changes to colorless. That means copper sulfate blue color changes to zinc sulfate colorless. So this is a change in color reaction, and this is also an example of displacement reaction. Like as we can see here, zinc react with sulfur and displace copper. So zinc sulfate form and copper displace हो गया. So this is also an example of displacement reaction. Now gas evolution means क्या होता है? gas evolution means formation of bubbles indicating gas release. अगर कोई chemical reaction में bubbles form हो रहा है, then we can say a chemical reaction is taking place and the gas is being released. Next, temperature change, the reaction mixture becoming warmer or cooler. Okay, now let's come to the next point, that is how we represent a chemical reaction. Okay, so simple representation of a chemical reaction: zinc solid reacts with 2HCl, that is hydrochloric acid, then it forms zinc chloride and hydrogen gas. So zinc react with chloride. This is also an example of displacement reaction. Okay, zinc react with chloride and displace hydrogen gas. Okay, now what does AQ means? AQ means aqueous, that is soluble in water. PPT means that is insoluble in water. S means solid, L means liquid, and Z means gas. So now balancing chemical equation. So why do we need to balance a chemical equation? एक chemical equation को balance करने की क्या ज़रूरत है? So we balance a chemical equation to obey the law of conservation of mass. Okay, so what does law of conservation of mass means? Law of conservation of mass means mass is neither created nor destroyed. That means the number of atoms of each element must be same on both sides of the equation. तो क्या इसमें क्या बोल रहा है? लाइक रेक्टेन में जितना नंबर होगा प्रोडक्ट में भी उतना ही नंबर होना पड़ेगा. सो रेक्टेन में यहाँ पे जितना होगा तो प्रोडक्ट में भी उतना ही नंबर होना पड़ेगा. सो दैट इज़ द बैलेंसिंग ऑफ केमिकल इक्वेशन. सो एंड this is achieved through the heat and trial method. The method that is mentioned in the NCERT book is heat and trial method, but we will follow a simpler way of balancing a chemical equation. I will show you that. So there is a simpler way to balance a chemical equation and I will show you that. So फर्स्ट बैलेंस द मेटल्स. ओके, द सिंपलर जो इजी तरीका है हम लोग को एक केमिकल रिएक्शन बैलेंस करने का, मैं आई विल शो यू दैट. आफ्टर दैट आई विल एक्सप्लेन द हीट एंड ट्रायल मेथड. ओके, सो यहाँ पे क्या होता है? फर्स्ट बैलेंस द मेटल. ओके, देन नॉन मेटल्स एंड देन हाइड्रोजन एंड ऑक्सीजन. सो फर्स्ट वी हैव टू बैलेंस द मेटल. So metal, sodium, potassium, magnesium, calcium, copper, like that we have to balance the metals. After that we have to balance the non-metals and then oxygen and then hydrogen. So here I am taking some example. So this is a unbalanced equation, so we have to balance it. Here let's see, here magnesium is 1, here magnesium is 1, so we don't have to change anything. Then here oxygen is 2, here oxygen is 1, so we have to add 2 here, right? Okay, we have to add 2 here. So oxygen 2, oxygen 2, here also oxygen is 2. Now let's see if it is balanced. Magnesium 1, but here magnesium is 2. Okay, so we have to add 2 here also. Okay, now it is a balanced chemical reaction. So what is the balanced chemical reaction? 2 Mg plus O2 gives 2 MgO. So now it is a balanced chemical equation. 2 Mg, oxygen 2 and oxygen 2. Now let's see the second one. Zinc plus HCl gives zinc chloride plus H2. So here zinc 1. Okay, all right. Next come to the non-metal part. Okay, zinc is the metal, zinc 1. Then come to the non-metal part, that is chloride. Chloride here is 2, so we have to add 2 here, right? We have to add 2 here, then it becomes chloride 2. So here 2 chloride and chloride 2. Okay, now it is balanced. Now again let's see if it is balanced. Zinc 1, okay, 2 chloride, then here it is 2 hydrogen, okay. So now it is a balanced chemical equation. So I will write the balanced chemical equation, that is zinc plus 2HCl gives zinc chloride plus H2. Okay, now let's come to the third point, that is iron plus water gives ferric oxide plus hydrogen. So how many iron is there? 1. Here iron is 3, so we have to add 3 here. Now let's see if it is balanced. 3 iron. Now come to the non-metal part. There is no non-metal, so we will go to oxygen. So here oxygen is 1, but here oxygen is 4, so we have to add 4 here. Then come to the hydrogen part. Okay, so 3 iron, now 4 oxygen, and then here hydrogen is 4 into 2, 4 to the 8 hydrogen is there, right? So we have to add 4 here, 4 to the 8, तो ये भी 8 हो जाएगा. So we have to add 4 here. Now let's see if it is balanced. 3 iron, 4 oxygen, then 4 to the 8 hydrogen, okay. So now it is a balanced chemical equation. I will write this: 3 iron plus 4 water gives ferric oxide plus hydrogen. Then let's come to the fourth point. Here barium is 1, here also barium is 1, okay. Now let's come to the aluminum. We have to first balance the metal, okay. So I will go to the aluminum part. So aluminum here is 2, here aluminum is 2, but here aluminum is 1, so we have to add 2 here. Then let's see if it is balanced. Barium 1, aluminum 2, okay. Now let's come to the non-metal part, that is chloride. Chloride here is 2, but here chloride is 3 2s are 6. There are 6 chloride, right? So we have to, so to get chloride 3, we have to add 3 here, right? So I will add 3 here. 3. So is it balanced now? 3 barium. Oh, let's see, here barium became 3, लेकिन यहाँ पे barium एक ही है, so we have to add barium, 3 barium here. So okay, now let's say 3 barium, aluminum 2, okay. Now come to the chloride. 3 2s are 6 chloride, so 3 2s are 6 chloride. Then let's see sulfur. Here it is 3 sulfur, right? As you can see here, 3 sulfur is there, so here also 3 sulfur, okay. Now oxygen, 4 3s are 12, oxygen is also 4 3s are 12. So I will write the balanced chemical equation, that is 3 barium chloride plus aluminum sulfate will give 3 barium sulfate and 2 aluminum chloride, okay. So this is the simpler way we can balance the chemical equation, okay. And now I will explain you the heat and trial method that is mentioned in the NCERT. Okay, so let's see. According to NCERT, the way to balance the chemical equation. So first we have to draw box formula. Draw box around each formula. Do not change anything inside. Next, list atom. Count atoms of each element on both sides, left hand side and right hand side. Okay. Then balance maximum atoms. Start with the compound having the most atoms, then the element with the most atoms within it. Okay. Now, okay, let's get into this. So I'm taking an example here. Iron plus water will give ferric oxide plus hydrogen gas. So step 1, what is step 1? Step 1 is to balance the chemical equation. Here see, first draw box around each formula, do not change anything inside. So here also it is written the same thing. First draw box around each formula, do not change anything inside the box while balancing the equation. So what is it saying here? It's saying that just draw box around the formula and do not change anything inside. So we have to just draw box like this, okay. After that, what is the second step? What second step is saying that list atoms, count atoms of each element on both sides, left hand side and right hand side, right? So let's see, list the number of atoms of different elements present in the unbalanced equation. So here we write the element, then number of atoms in the reactant, number of atoms in the reactant side, the number of atoms in the product, that is right hand side, product in the right hand side. Okay, so here iron is there. Iron, how many iron? One iron. In the product side, in the reactant side, there is only one iron, right? So we wrote 1. Then iron in the reactant side, it is 3. So it is 3. Now hydrogen is 2. Here also hydrogen is 2. Hydrogen is 2 on the reactant and product, both side hydrogen is 2. Okay, now oxygen part, oxygen is 1 on the reactant side and oxygen is 4 on the product side. Okay, so 4. Next, let's go to the third step, that is select the element which has maximum number of atoms. Okay, using this criteria, okay, we have to select now that has the maximum number of atoms from the equation, chemical equation. We have to select जहाँ पे ज़्यादा number of atoms present है. So यहाँ पे इस example में कहाँ पे present है ज़्यादा number of atoms? So Fe3O4 में ज़्यादा number of atoms present है. So here we are taking ferric oxide. Okay, so we select ferric oxide and the element oxygen in it. So we can, from the ferric oxide we can select anything. Okay, we can first, there is no hard and fast rule that we have to first take oxygen or we have to first take iron. There is nothing like that. We can take any of them like iron or oxygen. So select the element which has maximum number of atoms. Using this criteria we select ferric oxide and the element oxygen in it. So we select the oxygen in it. Okay, so here how many number of oxygen in the reactant side? In the reactant side it is number of oxygen is 1. Okay, here we could see that here number of oxygen is 1 and in the product side here number of oxygen is 4, right? So now we will balance it. So number of oxygen in reactant and in product. So initially कितना था? 1 in H2O. H2O में ही 1 एक ही hydrogen था, right? So 1 in H2O and 4 in, so oxygen 4 number, there are 4 number of atoms of oxygen in Fe3O4. So 4 in Fe3O4. Okay, now we have, so to balance it we have to add 4 in the reactant side, right? 4 in the reactant side because there is only one oxygen, so we have to add 4 here. So 4 H2O will be 4 will be added. Okay, to balance with the product side. So to equalize the number of atoms, it must be remembered that we cannot alter the formula of the compound or element involved in the reaction. For example, to balance oxygen atom, we can put coefficient 4 as 4H2O and not H2O4 this one. Okay, so what is it saying here? It is saying that we cannot add 4 like this. To balance the chemical equation, we cannot write the coefficient like H2O4 to balance it, to balance the oxygen number of oxygen atom. We cannot add 4 here. Okay, to add 4 we have to write like this, 4H2O. Always remember the coefficient will be added like this, not like this or not like this here. Or suppose hydrogen we need 5 hydrogen, so we cannot write like this. That means we cannot alter the formula. हम लोग जो formula है वो change नहीं कर सकते. We have to write the like coefficient here only. Okay, now let's see. Okay, so like this we have to add the coefficient here. Okay, so now let's get to the fourth step, that is, okay, now let's see the balance equation. Okay, so we balance oxygen, right? Oxygen, so we add 4 here to balance the number of oxygen. Okay, so now let's see the balance equation. Now the partly balance equation becomes iron plus 4H2O gives Fe3O4 then H2, right? So here number of oxygen is 4 and here also number of oxygen is 4. So now oxygen is balanced. Now let's get to the step 4. Iron and hydrogen atoms are still not balanced, right? So now we have to balance either iron or hydrogen. So here hydrogen is balanced, number of atoms of hydrogen to equalize the number of atoms of hydrogen. So let's see here. So now we have to take the partly balanced equation. Okay, now we cannot take this the main equation, so we have to take the partly balanced equation. So here number of the left hand side में कितना है number of hydrogen? 8. As you can see, 4 into 2, that is 4 2 is 8. So 8 hydrogen is there in the number of reactant side, and in the product side there is only 2 hydrogen, right? So we have to, so to get here to get 8, what we have to do, we have to add 4 here, right, like this, so that 4 2s are 8, it becomes 8 hydrogen, right. So to balance, in reactant side mein to 8 hai hi, right, 4 2s are 8 hai hi, so in the product side we have to add 4 here. So now the balance equation becomes iron plus 4H2, right. Next, sorry, 8H2, okay. Now 4 oxygen, so now oxygen and hydrogen is balanced here. Now we will balance iron. So let's see, initial iron, in the reactant side how many irons are there? There is only 1 iron, right. And in the product side there is 3 iron, so we have to add 3 in the reactant side, right. To balance the chemical equation we have to add 3 here, so 3 here, and then it is balanced. So now let's see, 3 iron, then 8 hydrogen, and then 4 oxygen, right. So this is the balanced chemical equation. Now we have to mention the physical state also, okay. To write here, as you could see here, to simple representation of a chemical reaction. So we represent the chemical reaction by mentioning the state also, okay, like it is solid or gas or liquid. So to make a chemical equation more informative, the physical states of the reactant and product are mentioned along with their chemical formula. The gaseous state is represented as G, liquid state is represented as L, aqueous state is represented as AQ, and solid state is represented as S. Of reactant and product are represented by this S, okay. Next, always remember, metal will always present in the solid state, okay, and water, here it is presented a gaseous state, but it is not like water will always present in the gaseous state. Water may present in solid state also, and water may present in liquid state also, but most of the metals will present in solid state only, okay. So iron will be in the solid state, water will be in the gaseous state here, and then ferric hydroxide will also be in the solid state, and hydrogen gas will evolve as a gas, okay. So now let's come to the next part, that is types of chemical reaction. There are 4 types of chemical reaction mentioned in your NCERT, that is combination reaction, then decomposition reaction, then displacement reaction, and double displacement reaction, okay. So first we will see the combination reaction. So what does combination reaction means? Combination reaction means a combination reaction is defined as a reaction where 2 or more substances react together to give a single product. So here 2 or more substances react together to give a single product, right. So here suppose we are seeing NaCl. So here Na plus Cl gives NaCl, right. So here 2 reactant मिलके एक product बनाया. So this is a example of combination reaction. So you can see here A plus B gives AB, right. So where A and B are the reactants and AB is the single product formed. So here we can see the reaction of magnesium with oxygen. 2Mg plus O2 gives 2 magnesium oxide. So this is the balanced chemical equation, right. So this is an example of combination reaction. 2 reactant react to give a single product. Okay, now let's see the activity part as it is mentioned in the book. So we have to take a burner, okay. We have to take a burner, then we have to take a tongue and a watch glass, okay, and we have to take a magnesium ribbon, okay. So first we have to clean the magnesium ribbon with a sandpaper. Then we have to burn that magnesium ribbon in the burner with a tongue. So when we burn the magnesium ribbon, यहाँ से जल के जो ऐश निकलेगा, मैग्नीशियम रिबन जब बर्न होगा तब जो ऐश निकलेगा, दैट वी विल कलेक्ट इन द वॉच ग्लास, ओके. सो हम लोग ने जो कलेक्ट किया ऐश, वो क्या है, वो है मैग्नीशियम ऑक्साइड, एंड दैट इज़ डेजलिंग वाइट फ्लेम फॉर्म्स वाइट मैग्नीशियम ऑक्साइड, दैट इज़ मैग्नीशियम ऑक्साइड. वॉच ग्लास में जो हम लोग ने ऐश कलेक्ट किया वो है मैग्नीशियम ऑक्साइड का पाउडर, वाइट मैग्नीशियम ऑक्साइड पाउडर, ओके. So this is the activity part that is mentioned here. So what happened? So एक मैग्नीशियम और ऑक्सीजन को जब बर्न किया तो मैग्नीशियम ऑक्साइड फॉर्म हुआ. That is completely a new property. मैग्नीशियम ऑक्साइड का प्रॉपर्टी कम्प्लीटली न्यू होगा मैग्नीशियम और ऑक्सीजन के comparatively. Okay, so this is a chemical reaction is taking place when we burnt a magnesium ribbon. Okay, now other examples of combination reactions are reaction with calcium oxide, reaction of calcium oxide with water. That is, here calcium and water react to form calcium oxide, right? Now combination of carbon and oxygen to form carbon dioxide, where here carbon and oxygen react to give carbon dioxide. So here two reactant react and give a single product. So this is an example of combination reaction. When two or more than two reactant react and give a single product, then this is an example of combination reaction. Either this or more than two or more than two reactant. So here it will be ABC like this. Okay, now let's come to the decomposition reaction. So what does decomposition reaction means? A decomposition reaction is a type of chemical reaction where one reactant splits into two or more products. Okay, यहाँ पे क्या होता है, यहाँ पे combination reaction का complete opposite है. combination reaction में क्या हुआ था, दो product मिलके दो reactant मिलके एक product बना था, right? So here एक product में जो एक रिएक्टेंट है, जो ए बी एक रिएक्टेंट है, उसका बॉन्ड ब्रेक होके सेपरेट हो जाएगा. सो यहाँ पे क्या बोल रहा है, वेयर वन रिएक्टेंट स्प्लिट्स, एक रिएक्टेंट स्प्लिट हो जाता है टू और मोर प्रोडक्ट्स में. ओके, यहाँ पे ए बी एक रिएक्टेंट है दैट इज स्प्लिट इनटू ए एंड बी, राइट? एंड इट यूजुअली हैपन्स विद द एप्लीकेशन ऑफ हीट. जब हम लोग हीट देते हैं तब वो बोन ब्रेक होता है. यहाँ पे क्या हुआ, यहाँ पे एक्चुअली बॉन्ड ही ब्रेक हुआ ना, ए और बी में एक बॉन्ड से रिएक्शन हुआ था एंड आफ्टर दैट आफ्टर डिकम्पोजिशन रिएक्शन ये सेपरेट हो गया. सो दैट मीन्स ए और बी का बॉन्ड ब्रेक हो गया, राइट? एंड वो बॉन्ड ब्रेक करने के लिए वी कैन ब्रेक इट आइदर थ्रू हीट और इलेक्ट्रिसिटी और लाइट एनर्जी. ओके, सो द जनरल इक्वेशन इज ए बी गिव्स ए प्लस बी, that is this a plus b. So that means one reactant splits into two or more product. So where AB is the reactant and A and B are the products. So here's the example of decomposition reaction, decomposition of ferrous sulfate. So ferrous sulfate, here it is ferrous sulfate. When we heated ferrous sulfate, it converts to ferric oxide, then sulfur dioxide gas and sulfur trioxide gas, right? So here we apply heat to break the FeSO4 bond. We apply heat, right? So when we apply heat, it breaks into ferric oxide, sulfur dioxide gas and sulfur trioxide gas. So here we can see a color change is also taking place. Okay, so ferrous sulfate crystals are green in color. On heating, it loses its water and changes to white color. On further heating, ferric oxide is formed, which is reddish brown in color. Okay, now let's see. As we all know, sulfur dioxide and sulfur trioxide are air pollutant and acidic in nature. Sulfur dioxide and sulfur trioxide causes air pollution. Okay, and that is acidic in nature. So let's see here, ferric hydroxide. So this is hydrated ferrous sulfate. Okay, this is hydrated ferrous sulfate. So why we are saying it is hydrated ferrous sulfate? Because there is the presence of water. If there is a presence of water, we will say that is in the hydrated form. And if water is absent, then we say it is present in the anhydrous form. Okay, so here it is present in the hydrated form. So ferrous sulfate, hydrated ferrous sulfate, that is green in color. When we give heat to this hydrated ferrous sulfate, it gets converted to ferrous sulfate. First it gets converted to ferrous sulfate and water. So ferrous sulfate is white in color. Then when we further heat those ferrous sulfate, we get ferric oxide. Okay, here we get ferric oxide and sulfur dioxide gas and sulfur trioxide gas. So here white changes to white ferrous sulfate changes to reddish brown ferric oxide, right? So यहाँ पे क्या हुआ, first green से white हुआ, white से reddish brown हुआ. That means first hydrated ferrous sulfate से ferrous sulfate बना. That means water separate हो गया heat देने से, और फिर ferrous sulfate फिर दोबारा heat देने से ferrous sulfate ferric oxide में convert हो गया. That is reddish brown in color. Okay, now let's see टाइप्स ऑफ डिकम्पोजिशन रिएक्शन. सो वी नो टाइप डिकम्पोजिशन रिएक्शन कैसे होता है, हीट देने से होता है, इलेक्ट्रिसिटी और लाइट एनर्जी देने से होता है. सो थर्मल डिकम्पोजिशन मीन्स व्हेन वी अप्लाई हीट टू ए केमिकल रिएक्शन. Okay. So a thermal decomposition reaction is defined as a decomposition reaction that is initiated by heating. जब हम लोग एक रिएक्शन में हीट डालते हैं और वहाँ पे जो रिएक्टेंट स्प्लिट होता है 2 और मोर प्रोडक्ट्स में, उसी को हम लोग थर्मल डिकम्पोजिशन बोलते हैं. सो द कंपाउंड इज़ ब्रोकन डाउन बाय हीटिंग. सो बोन ब्रेक हम लोग हीट से करते हैं, यहाँ पे हीट से बोन ब्रेक करते हैं, इसलिए थर्मल डिकम्पोजिशन. जब इलेक्ट्रिसिटी से बोन ब्रेक करेंगे तब इट विल बी इलेक्ट्रोलाइटिक डिकम्पोजिशन, एंड जब लाइट से बोन ब्रेक करेंगे तब इट विल बी फोटो डिकम्पोजिशन, राइट. So we'll see the first example, decomposition of calcium carbonate on heating. So here calcium carbonate, that is limestone, when we apply heat to it, it gets converts to calcium oxide, that is quicklime, and carbon dioxide gas is being evolved, right. So calcium oxide is called lime or quicklime. So we calcium oxide को quicklime बोलते हैं, and it has many uses, like one is in the used manufacture of cement. So this is the example of thermal decomposition reaction. Like heat apply करने से जो bone break होता है, जो calcium carbonate converts to calcium oxide. This is an example of thermal decomposition. Now let's come to electrolytic decomposition. That is when we apply electricity to it. When we apply electricity to break a bond, that is known as electrolytic decomposition. So example here it is to water. When we apply electricity in the water, it gets converts to hydrogen gas and oxygen gas. So it is an example of electrolytic decomposition. Now let's come to photo decomposition part. Photo decomposition means when we apply light to it, and it splits into 2 or more products, that is known as photo decomposition. The compound decomposes in the presence of light. So here silver chloride. In the silver chloride sunlight, we took silver chloride in sunlight, then it will get converted to silver and chloride. Okay, so this is an example of photo decomposition reaction. Now let's come to the displacement reaction. So displacement reaction में क्या होता है? Displacement reaction में a displacement reaction is a type of chemical reaction in which a more reactive element displaces a less reactive element from its compound. So here a more reactive element displaces a less reactive element. Okay, so here A plus BC gives AC plus B. So यहाँ पे reaction take place होने के लिए A should have to be more reactive. A is the more reactive element, BC compound of less reactive element, then AC is the new compound, and B is the displaced element. Okay, so as we could see, this is the reactivity series of metal. So we have to remember this. Okay, so you have to remember this reactivity series to follow a chemical reaction. Okay, so let's see the example. Iron here, where iron it is. So from the bottom to from bottom to in the upward direction, most reactive elements are there, and in the downward direction there is less reactive element. That means from bottom to up the reactivity increases. Okay, so here gold is the less reactive element and potassium is the most reactive element. So here the example is iron plus copper sulfate gives ferrous sulfate plus copper. So here where iron is this, iron is here, then where is copper is here, right? So definitely this reaction will take place. So iron will react with sulfur and displace copper. So here iron react with sulfur and copper has been displaced, right? So in this reaction iron is more reactive than copper, so iron displaces copper from copper sulfate solution. Next, another example is zinc plus copper sulfate gives zinc sulfate plus copper. So where zinc is here, then where copper is here. So definitely this reaction will take place because zinc is more reactive than copper. So here zinc will react with sulfur and displace copper. So zinc react with sulfur and displace copper. This is an example of displacement reaction. Then lead plus copper chloride, CuCl2. So lead here, it is lead, then copper is here, so definitely this reaction will also takes place. So zinc, since zinc is more reactive, lead is more reactive than copper, so definitely this reaction will take place. So zinc and lead are more reactive element than copper. They displace copper from its compound. So lead will react with chloride and displace copper. So this is an example of displacement reaction. Now let's see this copper plus lead sulfate. Copper plus lead sulfate. Here copper is here and lead is here. So definitely this reaction will not take place, as copper is less reactive than lead. As you can see here, copper is less reactive than lead. So this reaction cannot take place. Okay. So always remember the A element, the first element here, should always be more reactive than the BC element. Okay, BC compound. So first element should always be most reactive than the BC compound. Okay, so here this reaction cannot take place because lead is more reactive than copper. Now double displacement reaction. So next is double displacement reaction. A double displacement reaction is a type of reaction in which two compounds exchange their ions. Okay, here two compounds will exchange their ions to form टू न्यू कंपाउंड. दो कंपाउंड के बीच में आयन चेंज होगा और दो न्यू कंपाउंड बनेगा. दैट मीन्स आई विल शो हियर AB plus CD. AB and CD are two ionic compounds. Okay, then it will form AB, AD and CB. So A and D will exchange the ions to form AD, and B and C will exchange the ions to form BC, right? So it generally takes place in aqueous solution. Okay, always remember double displacement kind of reaction will takes place in aqueous solution and often result in the formation of precipitate. Either it will give precipitate or gas or a neutral compound like water. So here general equation is this. Here AB react with CD and it gave AD plus CB. So what happened? A exchange the ion with D and form AD, and here B exchange the ion with C and form CB. Okay, so here AB and CD are two ionic compounds. They exchange the ions to form AD and CB. So this is an example here. Sodium sulfate plus barium chloride reacts to give barium sulfate plus sodium chloride. So what happened here? Here sodium exchange the ion with chloride and form sodium chloride NaCl, and barium exchange the ion with sulfate and form barium sulfate. So this is an example of double displacement reaction. Okay, so sodium sulfate reacts with barium chloride. A white precipitate of barium sulfate is formed. Here barium sulfate is present in the form of PPT. Here white precipitate is present in the of barium sulfate is formed. This type of reaction where an insoluble substance precipitate is formed, this is also called as precipitation reaction. So अगर हम लोग कोई reaction कर रहे हैं and यहाँ वहाँ पे product में जो form हो रहा है वहाँ पर अगर PPT form हो रहा है, that means precipitate आ रहा है, then we can say that is a precipitation reaction. Okay, so which is a kind of double displacement reaction, because double displacement reaction में ही वहाँ पे product में PPT form हुआ. So this is a precipitation reaction which is a kind of double displacement reaction. Okay, I hope you understood well what I have explained. So here I am ending the class. Maybe two topics left, I think, oxidation and reduction. I will explain those two topics in a later class. So thank you.